Sound. Sound waves require a material medium for its propagation. Therefore, a sound produced at one point is heard at some other point after some finite time. This shows that sound has some finite velocity. We can hear a variety of sounds in our surroundings. In the music room of your school, you hear the sounds made by musical instruments like flute, phones, cycle bells, etc. In your room, you can hear your alarm clock, the sound from the moving blades of the fan, and so on. In your school, you can hear the ringing of your school bell, other children talking, etc. Some sounds are mild, some are loud, some are shrill, and some are flat. Each sound is unique. Even if we hear them after a long interval of time, we can recognize them easily.
Nature of sound and its propagation. Sound is produced due to vibrations. Hence, a vibrating object acts as a source of sound. Sound is a form of energy which is sensed by our ears. When an object vibrates in air, it compresses the air during forward motion. The compression increases air pressure. This compression propagates away from the vibrating object. During the backward direction of the vibrating object, particles spread apart and a low pressure zone is created in air. This is called rarefaction. These compression and rarefaction travel as wave passes through the air and reach our ears. Sound can therefore be called a pressure wave. Since the air particles are displaced along the direction of propagation of sound, hence sound is a longitudinal wave. The velocity of sound, that is, the distance travelled in 1 second, depends on the medium. The velocity of sound in different media is shown in the table. Longitudinal waves. Let's consider a spring particle system fixed to one end. When a single pull and push is given alternatively to the first particle at the other end of the system, the particles vibrate back and forth from its original position. As the particles are connected by the spring, the pull and push are also experienced by the next neighboring particle, and in turn it is also felt by the next particle, and so on. Hence, each particle of the spring particle system moves back and forth. During the wave motion, some of the particles come close to each other while some get apart. Regions where the particles come closer are called compression, and the regions where the particles are separated are called rarefaction. The regions of compression have higher density than the regions of rarefaction. Let us mark a point on the spring and observe its motion. You will observe the point moving left and right. Such waves in which the particles of the medium suffer displacement about their mean position along the direction of propagation of waves are called longitudinal waves. These waves travel in the form of compression and rarefaction. This table gives the difference between transverse and longitudinal waves. Transverse waves. The particles of medium oscillate around their mean position in a direction perpendicular to the direction of propagation of waves. Longitudinal waves. Particles vibrate along the direction of propagation of waves. Transverse waves. The waves move in the form of crest and trough. Longitudinal waves. The waves move in the form of compression and rarefaction. Transverse waves. It can propagate in solids and liquids only. Longitudinal waves. It can propagate in solids, liquids and gases. Transverse waves. Waves are of two types, transverse waves and longitudinal waves. Let us learn about transverse waves. Tie one end of a string with a rigid support and hold the other end with your hand. On moving the hand up and down, waves can be seen propagating in the string. Now mark a point on the string. You can notice that the mark moves up and down from its mean position perpendicular to the string, while the wave propagates in the horizontal direction along the length of the string. Such waves in which the displacement of the particles of the medium is perpendicular to the direction of propagation are known as transverse waves. These waves move in the form of crest and trough. Crest represents maximum displacement in the upward direction, and the trough represents maximum displacement in the downward direction. Range of hearing in humans. Sound is produced when a body vibrates. We can hear the sound produced by a body which vibrates in a particular range of frequency. The range of frequencies that human ear can hear is from 20 Hz to 20,000 Hz. These frequencies are called audible frequencies, and the sound in this range is called audible sounds. Upper limit of hearing decreases with increasing age. The sound with the frequency less than 20 Hz is not audible by human beings. The sounds of frequency below 20 Hz are called infrasonic sound. Animals like elephants, whales and rhinos can hear these sounds. Sounds of frequencies beyond 20,000 Hz or 20 kHz are called ultrasonic sounds. Animals like dogs, dolphins and bats can hear ultrasonic sound. These types of sounds are used widely in medical field. Applications of ultrasound. Sounds of frequencies beyond 20,000 Hz are called ultrasonic sounds. Ultrasound is used to clean inaccessible parts of small objects. The object to be cleaned is placed in a solution and ultrasound is transmitted through the solution. The ultrasound removes the dirt from the object. Ultrasound can be used to detect flaw and cracks in metal blocks used in making big buildings and bridges. Ultrasonic waves are passed through metal moldings and transmitted waves are detected. If there is any defect, the ultrasound gets reflected back, showing the defect. Bats and dolphins emit ultrasonic waves to locate and identify objects in its environment. Coming to the medical field, ultrasound is used to get the information about the internal organs like bladders, kidneys, ovaries, pancreas, etc. This technique is known as ultrasonography. Ultrasonography can also be used to examine fetus during pregnancy to detect growth abnormalities. When the ultrasound is used to examine the heart, it is called echocardiography. It is used in diagnosis of heart diseases. Reflection of sound. Like light, sound also gets reflected and obeys laws of reflection. If we shout inside an empty hall or a mountain, we will hear the same sound again a little later. The sound heard after reflection from a rigid surface is called echo. Imagine that you are standing in front of a mountain which is at a distance d from you, and let the speed of sound in air be v. Suppose you shout. The distance covered by the sound to reach the mountain and come back to you is 2d, and the time taken is t. The sensation of sound persists in our ear for about 0.1 second. Thus, to hear a distinct echo, the time interval between the original sound and the reflected sound must be greater or equal to 0.1 second. By substituting t equals to 0.1 second and v equals to 344 meters per second in air, we get d equals to 344 meters per second into 0.1 second divided by 2, which is equal to 17.2 meters. Therefore, to hear the echo distinctly, the reflecting surface should be at a minimum distance of 17.2 meters from the listener. Echoes may be heard more than once. St. Paul Church in London is known as Whispering Gallery. Here, sound is echoed many times. This is due to multiple reflections from number of reflecting surfaces. Whenever sound is repeatedly deflected from a hall, it persists for a much longer duration till its intensity decreases below the audible limit. Such persistence of sound due to repeated reflection is known as reverberation. In order to reduce reverberations, the ceiling and walls are laid with sound-absorbing materials such as compressed fiberboard, plaster, or curtain. Practical applications of reflection of sound. Sound waves get reflected from the hard surfaces such as wall. Some devices such as megaphone, horn and trumpet use multiple reflection of sound to work. A megaphone prevents the spreading of sound by successive reflections confined within the tube. In this instrument, a tube followed by a conical opening reflects sound successively to guide most of the sound waves from the source in the forward direction towards the audience. Horns and trumpets are also designed to send sound in a particular direction without spreading it in all directions. A hearing aid is a type of device that is used by persons with impaired capacity for hearing. In this device, the sound enters through the conical inlet and suffers multiple reflections before entering into the narrow area of the ear. This helps in increasing the amplitude of the sound. Stethoscope is medical equipment with a thin diaphragm which is kept in contact with the patient's heart. The sound of the patient's heartbeat reaches the doctor's ears by multiple reflection of sound as shown. Generally, the ceilings of auditorium are curved so that sound after reflection reaches all corners of the hall as shown. Sometimes a curved sound screen is placed behind the stage so that the sound after reflecting from the sound screen spreads evenly across the width of the hall.
Noise pollution. Too much noise is known as noise pollution. Automobiles, buses, heavy machines in factories, loud uproar from religious, cultural and political gatherings, rock bands, loudspeakers, etc. are the main causes of noise pollution. It can cause irritability, loss of concentration, high blood pressure, headache, stress, sleep disturbances, and can even damage hearing permanently.